Okay, today's aim is how do we reflect a given point over another point? Okay, so reflecting a point over a point. So let's take an example. Given point A, 3, 6, how can you find the coordinate of A prime after a reflection over minus 2, minus 1? So let's see what this looks like. I've got point 36, and I want to reflect point 36, which is point A, over minus 2, minus 1. So what are the properties that we've learned about reflections? Well, if you remember, one of the things we've learned is that the distance of the pre-image and the image to the line of reflection are equal. In other words, if you wanted to reflect point P over this line of reflection, this dashed line, the distance that B is from the line of reflection is the same distance as B prime from the line of reflection. These are exactly the same in length. Well, the same also applies to when you're reflecting over a point. In other words, the distance from A to P, this distance over here, has to be the same distance as P is from the image after the reflection. So I know that the neighborhood of A prime should be somewhere over here, but we want to find out exactly where it is. Well, this should seem very familiar to you. We learned the midpoint formula back in September. In other words, if I gave you one point, namely A, and I gave you the midpoint between A and A prime, how do you find A prime? You use the midpoint formula. So if you remember, the midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. This will give me the midpoint of a line segment. This is when I know the two of the endpoints, point 1 and point 2. Here I'm given x1 and y1, which is right over here. This is x1, y1. Imagine I'm looking for x2, y2, basically A prime's x and y value, and I'm given the midpoint. This is the midpoint, right? So what we're going to do is we're going to apply the midpoint formula in the same way as we did back in September. So because this point is going to be called A prime, I'm going to be calling x's value x prime and y's value y prime. That is going to be point A prime's x and y value. So here we go. So I know that this is the midpoint. The midpoint's x and y value. So what is the midpoint's x value? Well, that's minus 2. So minus 2 is equal to 3, right? That is A's x value right over here, 3, plus x prime over, sorry, call that x prime, not x squared, x prime over 2. That is going to be, this is going to help me find A prime's x value. And to find A prime's y value, well, I know that my y value for A is 6. So I know that y prime, if I add 6 plus y prime over 2, that is going to be equal to negative 1. That's this value over here. This is the midpoint's y value. Y value right over here. So minus 1 is equal to 6 plus y prime over 2. Let's solve. So first what I'm going to do is to solve for x prime. I simply multiply both sides by 2 to get rid of these 2's. 2 times negative 2 is a negative 4, and I have 3 plus x is equal to 3 plus x. If you, let me move this down. Let me move everything down here. There we go. So if I subtract 3 from both sides of my equation, x is equal to negative 7. So this is x prime. X prime is equal to negative 7. And now let's find y prime's value. So again, what I'm going to do is I'm going to multiply both sides by positive 2 to get rid of these 2's right over here. And I have 2 times negative 1, which is a negative 2, is equal to 6 plus y prime. Again, I subtract 6 from both sides of my equation. Y prime is equal to negative 8. So it looks like I expect A prime to be negative 7, comma, negative 8. So negative 7, 2, 4, 6, negative 7, 2, 4, 6, 8, which is right over here, which is exactly where, in the neighborhood of where I expected it to be. So my a prime's x and y value is going to be -7, -8. So I have -7, -8 as the value of a prime. Those are the coordinates of a prime. Okay. So when reflecting a point over a point, that point of reflection becomes the midpoint of the pre-image and the image. In the same way that this point over here became the midpoint of B and B prime, in that same way, this point over here, namely -2, -1, became the midpoint of A and A prime. Here's another way of thinking about this. So what we're going to do is let's clone this page and let's clear everything from it. Okay, another way of thinking about this is as follows. So -2, -1 is, that is my P, the point that I'm reflecting over, and 3, 6, 3, 2, 4, 6, 3, 6 is my original point. So I can think of this as follows. How many units down and how many units across do I need to get from point A to point -2, -1? Well, let's see. I went down 1, 2, let's see, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5. So I went down 7 units, and I went to the left 5 units. So again, I have to continue going the same distance down and the same distance across. So 1, 2, 3, 4, 5, 6, 7, and then 5 units to the left, 1, 2, 3, 4, 5. So this is the point which is going to be A prime. And what is this coordinate? So 1, 2, 3, 4, 5, 6, 7. That's -7, 2, 4, 6, 8. So that again is -7, -8, or -7, -8. That is the coordinate of A prime. That's another way of thinking about it. And the reason this works is as follows. Number one, we know that the distance from the line of reflection, or in this case the point of reflection of the pre-image, which is this guy, and the image, which is that guy, has got to be the same. And notice how these two are the same. In other words, if you drew a line from A to P, that would be the same distance as A prime is to P. It would have to be, because if this is 5 and this is 7 units, in other words, this is 5 units big, this is 7 units big, and if this again is 7 units big and this is 5 units big, we've got two right triangles, and by side angle side, these two triangles are congruent, which means all their corresponding parts are also congruent, namely the hypotenuses must be congruent. Okay, why don't you try one yourself? Find P prime, the image of P -3, 5 after a reflection in the origin. Put your player on pause, try to do this on your own, and see how far you get, and then hit play to resume. Okay, so the image of P -3, 5, let's count what that is. So -3, 1, 2, 3, 5, 2, 4, 5, which is right over here. So that's P -3, 5. I'm reflecting that over the origin. Where is the origin? Well, the origin is right over here. That's 0, 0. That is the origin. So if I'm reflecting over the origin, I can use the midpoint formula if you wanted to, or what you can do is do what we just did before. In other words, let me count how many units down and across I need to go, and then let me do the same thing in the opposite direction. Go down and across the same number of units. Let's see what we got. We have 1, 2, 3, 4, 5, and then 1, 2, 3. So I went 5 units down, and I went 3 units across. So again, I'm going to go 5 units down, 1, 2, 3, 4, 5, and then 3 units across, 1, 2, 3. So this is going to be my point P prime. And let's see what that is. That is 3 minus 5. 3 minus 5. So you've noticed something very interesting here. Look at the pre-image, which is this, and look at the image, which is that. What has happened to our coordinates? I started off with -3, 5, and the reflection over the origin is 3 minus 5. So notice how the x and y values stayed the same, but their signs changed. So instead of a -3, that was my pre-image, I have a +3. And for my y value, instead of a +5 as my pre-image, I have a -5 as my image. Okay, and that's the end of this lesson on reflecting over a point.